This is going to be part B of the Unit 4, Math Plus Red, which focused on the extended problem solving, and the unit was lines, angles, and rotations. And as I mentioned in Part A lot of these extended problems do focus on real-world situations, and they do require problem solving. And we want students to see that we use math every day, and that it is important to persevere and to use problem solving. We're not always going to be able to just spit out an answer, but we are able to use tools and different materials to figure out things. We often make mistakes along the way, but we learn from those mistakes. Now, question number 3 does talk about some measurement, but it focuses a little bit about, in addition to measurement and area, it focuses on multiplication and division skills, and we're also going to get into perimeter. And area and perimeter were both things that were introduced in 3rd grade, but we're taking it a step further with larger numbers, and this is going to be covered more thoroughly later on in 4th grade. But when working with area and square units, I do highly recommend getting graph paper so that students can see that it is based on the number of squares inside the rectangle. That will help you make things a little more visual. For now, I'm just going to simply draw a little rectangle here just for your sake, and to show that we're really showing there's 128 square feet inside this rectangle. We also know there's 8 feet on each side, or the width of our garden, but we don't know the length of the garden. But when we think back to the 3rd grade skills, and this is something you can easily model with blocks and things like that, build an array to remind students that if you have an array and you have 2 rows with 5 in each row, that would be 10. We have 2 rows of 5. Here we have 8 rows with how many in each row equals 128. We don't know that unknown number yet, but we can also remind students to think about how multiplication and division are related, and we can use our knowledge of fact families, and we can take that total, divide it by the factor that we know, to come up with that unknown number. So when we divide 128 by 8, we really need to avoid using the standard algorithm, and we really want students to think about place value in this number as a whole. So often students think, well, I'm going to divide 8 into 1. Well, this 1 is not just a 1, it's a 100. So we really need to think about this entire number and use the facts that we know to help solve it. I know that 8 times 10 is 80. So I can easily take away 8 or 10 groups of 8. If I have 8 take away 0, it's 8. 12 take away 4, 8 is 48. So I also know that 8 can go evenly into 48 because 8 times 6 is 48, and I end up with nothing left over, so it divides evenly. When I add up these partial quotients, I get 16. So it went in or divided evenly a total of 16 times. So now I know that my missing length that I didn't know earlier is 16. So to find the perimeter, we want students to think about if you walk all the way around and we add 16 plus 8 plus 16 plus 8, what would we get? So that would be the perimeter of this shape. Now, as we move on, this section does get a little tricky. And this is where we want students to maybe use models. I think Lego blocks or some sort of manipulative would be really great to use. But we want students to really think about that measurement. And that right now we're talking about inches, but up here we were talking about feet. And we can talk about, are inches and feet the same thing? How many inches are in a foot? So with these bricks, it's going to take 2 bricks to equal 1 foot. And if you look at the lesson guide, or the answer key that is in the lesson guide for this extended problem solving, you'll notice that they were able to lay out the blocks. That's why I think Legos would be really cool to use. And then you get to have that conversation about, well, what do we do about the corners? Do we need to divide a brick in half and use it for 1/2 for each corner, just like they would do on a house? Because if we just have a whole brick on each side, then our measurement is going to be off. So again, great problem solving activities. So basically you're going to count up how many bricks you would use. When we head down into problem number 4, we get to get out our protractor again, which is really fun. And it's even funner because we're going to measure pizza. And one thing that is really important for students to realize in fourth grade is that when we go around and we measure angles, if we continue to go around, we're going to end up in a circle. And a circle has 360 degrees in the whole circle. And if I draw a line right down the half or in the middle, I know there's 180 degrees on this side and 180 degrees on this side. So it's important to really think about that. 360 degrees in the entire circle and 180 on each side. So what we were given is that the slice of pizza that's angle L is 45 degrees. So I'm going to write 45 degrees. I also know that this is a right angle, so this piece is going to be 90 degrees. Now, when I try to come up with the missing angles here, I know that all three of these on this side are going to need to add up to 180, or otherwise my measurements are off. But this is fun because it really helps students use that protractor, practice lining it up the right way, putting that right in the center, and then measuring. And we always want to start with 0. And so this one is 30 degrees. And then I could do the same. And again, it's, I think, moving the protractor in so many different ways around the circle is going to be helpful for them to line it up and practice measuring. And this one is 60 degrees. And I know that this is 90 and this is 90 and equals 180. So you can continue around that circle and fill in those measurements on the chart that was right here in number 4. Now, there is a part B to this question, and it says, Jonathan buys a slice of pizza that's the same size as slice M. So slice M, if we looked at the chart, was $3. $3, and it's 90 degrees. And it says Addison buys 2 slices of pizza that are both the same size as the slice L. And if I look back at the chart, I see that slice L is $1.75, and she buys 2 of those. And each of those are 45 degrees. Now, this is where you could really have your child do some problem solving and say, well, is 245 degrees the same as 90? Which is a better deal? If we add this up, which one would cost more? Should she buy just one big piece, or should they buy 2 smaller pieces? What's the best deal? Because they both might be the same amount. And we really want to focus on that. Explain why. Explain how you know. Who got the better deal? Now, as we move on to number 5, this part says, use this drawing to answer parts C and D. Or actually, it's still number 4, but just 2 additional parts. Just like we did before, always take these measurements and place it on the diagram. We want students to really use that scratch paper. We want them to pick up those pencils, because when they see it on here, it's much easier. The S is 20 degrees and the T is 20 degrees. Just like before, when we divide a circle directly in half, this side's going to be 180 degrees and this side's going to be 180 degrees. The entire circle is 360 degrees. We can also think of a clock as a great way to practice determining our angles as the minute hand moves around the clock. So the question is, how much greater is the measure of angle R than these 2 combined? So we need to subtract. When we compare, we have 140, and it says combined, take away 40. So it's 100 times greater, or it's 100 greater, 100 degrees greater. So now, when we go down to section D, it says angles U, V, and W, right here, are all the same size. So we have 3 angles that are the same size. Addison correctly says she knows the measure of U, V, and W without measuring each of them. What is the measure of each of these 3 angles? Explain how you know. So we're not supposed to get out the protractor on this one. But what we're supposed to do is take that 180 and think about, how can we divide that 3 times to get the same amount in each angle? And if we divide 180 3 times, again, let's think about things we know. Let's think about, I know that 3 times 50, because I know 3 times 5 is 15, and I'll make it 10 times bigger. So 3 times 50 is 150, so that makes this a lot smaller. And if I subtract, I get 30, and that's easy. I know 3 times 10 is 30. And so I can take away another 10 groups, and I end up with 0 left over. So when I add my partial quotients together, I have 60. So each of these angles would be 60 degrees. Now, when you are helping your child through this extended problem solving, encourage them to persevere. Encourage them to make mistakes. Encourage them, if they get the wrong answer, to add it up to see if it equals 180. Encourage them to try again. That's what